So this is part of Val Barber's PhD, where she looked at the measured climate at Fairbanks goes back about 100 years and developed the May through August mean temperature, and then correlated that with tree ring late wood density and isotopes and found a really strong correlation. And then based on that correlation, she could go back 200 years. So it turns out that now our summer temperatures are the highest they've been in the last 200 years. And in fact, in 2004, we're off this graph. In 2004, the summer temperature, May through August, was 16.4 degrees centigrade. And yet, surprisingly, the response of peak summer NDVI is very similar if we look at a warm, nearly permafrost-free watershed basin compared to a cold, permafrost-dominated watershed basin. So 2003 was a wet year, so both sites basically responded to an increased NDVI in 2004, and then they declined in NDVI following the 2004 drought. And this is surprising because you would expect this cold permafrost basin to be buffered against the effect of hot summer drought relative to this warm permafrost-free basin. So here are similar results from Walker et al., where they looked at black spruce tree rings on a variety of sites. So in this example, we have north-facing slopes versus south-facing slopes from 1980 to 2005, and they found very similar patterns despite the fact that these north-facing slopes are much colder sites than these south-facing slopes. And you would think that it would be good to be on a cold site with a warming climate, and that would buffer against these hot, dry summers. Well, there's two potential mechanisms on these cold sites, and one is spring drought stress. So here's an example from Berg and Chapin, 1994, and in late May, there's canopy water stress, and what happens is the rooting zone is frozen, and above ground it's warm and windy with low humidity and long day lengths. So basically we have canopy drought stress when the root zone is frozen. And then the second mechanism is if we look at a typical soil temperature profile at 20 degrees centimeters, so 20 centimeters down for black spruce, it does not thaw until the beginning of July. So consequently, the rooting zone for a cold black spruce site is a very shallow rooting zone because of these extremely cold soils. And therefore, if most of the fine roots are above 20 centimeters, that shallow rooting zone is going to be susceptible to summer drought.